When it comes to building engines, one thing that seems to confuse a lot of people is degreeing in the cam. Now, it's not that tough of a process, but it is absolutely critical because the camshaft controls when the valves are open and closed, and you want those controlled precisely so you can make the most power. Now, I'm working on this project here with a World Products Motown 2 block and an Erson cam, and as you can see, I'm all set up to degree the cam in. So we'll work through the process and see that it's actually a lot easier than a lot of people think. The cam I'm using is an Erson roller with 264 degrees of duration at 50 thousandths lift and 430 thousandths lobe lift. But this process will work with any cam. It doesn't matter if it is solid or hydraulic, and it works the same with any cam and block engine. So with plenty of assembly lube on the journals, I stabbed the cam into the World Motown 2 block and installed the timing set. I just ran in a couple of bolts to secure the timing set for now, and I'll add a cam button and torque everything up properly later on. Make sure to install the timing set with the dots from the two gears facing each other like you see here. With the cam and timing set in place, I installed the degree wheel, a wire pointer, and a dial indicator on a deck bridge. I wasn't thinking, but what you really want here is a single dial indicator in the center of the bridge, and I'll explain why in just a moment. Now, your first step is to dial in piston top dead center on your number 1 hole with your degree wheel. A lot of people can do that with a deck bridge and a hard stop. I just prefer to do it with a set of dial indicators. Either way works perfectly well. Now you can see I've changed my setup here from the start a little bit. I just wanted my deck bridge with a single dial indicator set right to the middle of the piston. That way if the piston rocks a little bit, you're always right in the center. If you got 2 on either side, which is the way I had it set up before, if you're off, it just makes it a little bit tougher to get exactly right. Now what you want to do as you get started is back the piston off and then set what you can eyeball as your TDC. Right there. Now I'm going to back off, bring it down in the hole, about 50 thousandths, and mark my spot on my degree wheel here. Always make sure you're doing this in the direction of engine rotation, in other words, clockwise. If you go too far, don't just back up to it like this, because any slack in the timing chain can throw your measurements off. Instead, back up a little bit too far and come at it again, once again, clockwise. So 62 degrees is my mark for 50 thousandths before top dead lift. I'll just mark 62 on my notepad. Now I'm going to roll it through TDC and back 50 thousandths drop on the other way and mark your position again. This time I've got 38. True TDC is the midpoint between 62 and 38 degrees. So I'll just average the two and my target is 50 degrees on the degree wheel. Okay, so now we know exactly where piston TDC is. It's at 50 on the degree wheel. So we can go there now. And then once we have 50 set up, we can reset the degree wheel to put 0 at TDC. Now granted, this is a really nice degree wheel. I'm using it because it's large and well printed and it makes it easy for me to illustrate to you exactly what's going on. But if you have a small wheel like this, it will work just as well. You've just got to be careful and precise. I'll slide a set of lifters into the bores for the number 1 cylinder, remove the deck bridge and replace it with a dial indicator on a magnetic stand. Then install a push rod, and it doesn't have to be the correct length for this application. It goes between the intake lifter and the dial indicator. Make sure the push rod and dial indicator are all in a straight line with the movement of the lifter. Every new cam should come with a cam sheet with all the critical lift and timing numbers. What's important to us is the intake lobe center line. Erson tells us it's at 106 degrees. So now we are ready to get down to business. We know the intake center line is 106 degrees. We've got the dial indicator set up to track movement of the intake lobe, and all we have to do is see where it falls into place. The process for determining intake center line is basically the same as what we did when we found the piston top dead center. We're going to track on either side of maximum valve lift. This time we're going to 20 thousandths on either side of maximum lift. The reason why we're not going to 50 thousandths like we did when we found TDC is if you have a cam lobe that's asymmetrically ground, meaning that the lift side is slightly different than the closing side, it can screw up your readings. By going to 20 thousandths, we're just a little bit closer to the top, and it makes you more accurate in this situation. If you're comfortable with the process of finding TDC like we just finished, then verifying intake lobe center line will be a piece of cake. Just like before, find the lobe's maximum lift on the dial indicator, then roll the engine back and find the mark on the degree wheel at 20 thousandths of an inch before maximum lobe lift. For us, it's going to be 80 degrees. Next, roll the engine forward until you have the dial indicator at 20 thousandths after maximum lobe lift. Now don't get confused here, this is not actually 52. The degree wheel stops at every 90 degrees, so we continue to 90, 100, 110, 120, 130, 12. 132 degrees is what we're counting here. So just like before, we take our two numbers, add them together, and divide by 2. And the result is 106, exactly what Erson's cam sheet says it should be. So since we've verified the correct cam timing, we can be confident continuing with the engine build. One more quick note. Now, your timing is not always going to be dead nuts on just like that. If you need to move it, there are different ways to do it. Now, this particular timing set is a PBM performance timing set, and it's actually a 2-piece top gear, which really makes timing adjustments easy. First of all, there's a scale printed on the gear right here, and as you can see, we've got it zeroed out, and it allows up to 4 or a little bit more, 6 degrees of timing adjustment, either advanced or retarded. Now to do that, all you do is loosen up these bolts right here, which locks the gear together, and you take this tool right here, it slots into this location here or this location here, and with the screwdriver, it's cammed so you can move it to advance or retard exactly where you want it on the scale, and then lock it right back down. Once you've done that, you're good to go. So there you have it. It's as simple as that. Degreeing in your cam is straightforward, it's easy, and it is critical if you want to make sure that you are making the most power on every engine build. Hey, thanks for watching.